Okay, so in this video we're going to do some examples of integration by parts. This is something where the best way to learn it and to get the hang of it is to really just see a bunch of examples and see how it's done. But we're going to be using this formula, the integration by parts formula. Integral of u dv is equal to uv minus integral of v du. And without really going into too much depth about what this means, we're just going to kind of pick it up as we go, as we use it. Of course, it comes from the product rule. The product rule. You work backwards from the product rule the same way that u substitution comes from the chain rule. But we're just going to see how this goes, and it'll sort of become clear what the process is and what this means, more than you could sort of understand it from an abstract definition or explanation. So let's do our first example. Let's do integral of x times e to the x dx. So the tip-off that you want to use integration by parts is usually that you can't use u substitution, right? If I had e to the x squared times x, then I would have a function of a function, so e composed with the squaring function, and then I'd have the derivative of that function, right? Or a scalar multiple of the derivative of that function. I could set u is equal to x squared, then du dx is 2x, making dx, or du rather, making du equal to 2x dx, and then I could substitute this in and get 1 over 2 e to the u du. So that's when you have this pattern where it's a function of a function multiplied by the derivative of that function. If I don't have that, right? If I don't have this x squared, it's just x e to the x, then I have to start thinking about something else that I can do. And integration by parts is one of those things. It works for products of functions. So I have a x times an e to the x, so a product of two functions, and I can't use u sub, so this is where I'm going to use integration by parts. So in this case, I'm going to set x to be equal to u. That means that dx is equal to du, and dv is equal to e to the x, which makes v equal to also e to the x. So remember, when we're picking these, I know that whichever thing I pick for u, I'm going to take the derivative of it, right? I'm going to immediately take the derivative of it, because this means that du dx is equal to 1, which is where I get the dx du from. So I immediately take the derivative of u, and with v, right, or with dv, I immediately take the integral of dv, which is v, because that's the fundamental theorem of calculus, part 1, integrals undo derivatives. So when I'm thinking about this, I'm thinking, when I decide which one to pick, I pick the x to be u, because that makes du equal to dx. It makes the x basically go away, and that simplifies things. And I know also that I can take the integral of dv e to the x really easy. E is its own integral. So that's really simple. When you pick the dv, you want to make sure that the thing that you're picking to be dv, you can actually integrate. Typically, it's pretty easy or pretty straightforward to take a derivative, but it's much harder to integrate a random function that you pick. You can't just do it. You can't just pick any function and integrate it the way you can take the derivative of basically any function. So that's sort of one of the things that stresses people the most is, how do I make that choice? Well, this is one of the things that I think about when I'm making that choice. And then, once I do that, once these choices are made, I'm going to apply my formula. Integral of u dv is uv minus integral of v du. I like to actually just write this out every time so that I can very clearly know. I've been doing this for many years. I still like to actually write it out so that I can see where I'm going to put each thing and make sure that I have it straight. One less thing to sort of remember as I'm doing it. So my integral of u dv, of course, is integral of x e to the x dx, and it's going to be u, which is x, times v, which is e to the x, minus integral of v, which is e to the x, times du, which is dx. And of course, the integral of e to the x is just e to the x. So this is x e to the x minus e to the x, and then we can't forget the plus c. And so if I want to check this, how can I check that this is correct? Well, I take the derivative, right? This is supposed to be the antiderivative of x e to the x. So I just compute d by dx. This is how to check d by dx of x e to the x minus e to the x and plus c, which is of course going to go away. This becomes d by dx of x e to the x minus d by dx of e to the x plus d by dx of c. D by dx of x e to the x is, I have to use the product rule. It's d by dx of x times e to the x plus x times d by dx of e to the x. D by dx of e to the x here, the one I've done there, I'm subtracting. That's, of course, just e to the x. And then the derivative of c with respect to x is just 0 because c is a constant. Now I go to the next line. Derivative with respect to x of x is just 1 times e to the x, then plus x. Again, d by dx of e to the x is just e to the x, so this ends up being x e to the x, and then I'm subtracting e to the x. The positive e to the x and the negative e to the x cancel, and I just end up with x e to the x, and that is what we were looking for. That's what I was hoping this was going to be, so that's good. It checks out.